Good afternoon, dear students. Yes. So I hope you have gone through the synopsis, okay, which is sent to you already. So today we are going to start with a new topic, okay. So with another organic chapter, that is amines, okay. So that is the organic compounds containing nitrogen atom, right? So we have seen haloalkanes, haloarenes, alcohol, phenols, and ethers, aldehyde, ketones, and carboxylic acid. Today we are going to see amines chapter. Okay. So we are going to deal with this chapter. Okay. And we are going to solve some MCQs. So I hope the students who are joining now, yes, so have already gone through the synopsis. Right. So let us start solving the MCQs based on this chapter. Okay. So I have taken such questions so that it will cover the entire concept, okay, based on the amines chapter. So let us start with this question. Okay, so the first question is, so you have a nitrobenzene, okay, you have a nitrobenzene and you are reacting it with that is your tin. Okay, you are reacting it with tin in the presence of HCl. Okay, so you yield a compound, you get yield a product. Okay, so it is a X. Okay, it is a X. So it is not your halogen atom X. So they have substituted some what you say substituent is there. Okay, there is some substituent X. So you have to tell on the benzene ring. So what this X stands for? Is it a amine group? Is it a tin chloride? Is it a chlorine group? Or is it a ammonium chloride group? Okay. So Tasmia has answered it as A. Others? Yes. Try answering. What about others? So it is a nitrobenzene, right? We have a nitrobenzene that is on a benzene ring. We have a nitro group, right? So we have a nitrobenzene. So this nitrobenzene, we are reacting it with what? Tin and HCl. And what is the role of tin and HCl? Tin and HCl is a, yes, students, it is a reducing agent. Okay. Now, what is the role of a reducing agent? It will add hydrogen or remove oxygen. So these reducing agent will undergo what? It will undergo reduction. So what is possible here? Okay. So what is there? We are going to remove this oxygen and we are going to add hydrogen. So this is what? It will yield you what? It will yield you aniline. Okay. So this is a reduction method. So this is we are doing reduction on nitrobenzene to give you aniline. So what is our X stands for? It is A. Okay, it is A. Yes, Tasmia, your answer is correct. Very good. Okay, so go through the, yes, the students who have joined now. So go through the question. So we were discussing this particular question where we have a nitrobenzene. We are reacting it with tin and HCl. What is the role of tin and HCl? Tin and HCl, it is used as a reducing agent. Okay, so it will undergo reduction. So what is reduction? Reduction is addition of hydrogen or removal of oxygen, right? So here what is happening? So you have two oxygens. So these two oxygens are replaced by H2, right? That is hydrogen. What we yield? We yield the aniline. So option number A is the correct answer. Okay, so let us go for the next one. Gabriel thalamide synthesis is used for the preparation of So Gabriel, you might have gone through the Gabriel thalamide, the famous reaction that is a Gabriel thalamide synthesis. Okay, so it is one of the important reaction in amines. Okay, preparation of amines. So what type of amines are prepared? Okay, synthesis means prepared. Okay, so what type of amines are prepared? A aromatic amines, primary aromatic amines, B secondary amines, C primary aliphatic amines, and D tertiary amines. Okay, Vedvati has answered it as A. Tasmia has answered it as C. Vedvati has answered it as C, and Basava has also answered it as C. Okay, so let's go. So, so in the synthesis of Gabriel thalamide synthesis, okay, what we obtained is we obtained a primary aliphatic amines. Okay, how is this reaction possible? Yes, so we have a thalamide. So we have a thalamide. So this is a thalamide. Okay, so this is a compound called thalamide. So this thalamide, we are going to react it with KOH. Then what we get? We get a, so the rest all the compound remains the same. Okay, so only change will be at this C double bond O, okay, and N minus K plus. So it becomes a potassium salt of thalamide. Okay, so this only at this site the reaction takes place. Okay, so Vamshi Krishna has answered as A. So answer is C. Let us see how the reaction takes place. Just a second. Yes, so let us continue. So what we have a thalamide. Okay, we have a thalamide here. So this thalamide, thalamide, this we have treated with what? Potassium hydroxide. Then what we get? We get a potassium salt of thalamide. Okay, so your hydrogens are what? That is N potassium thalamide. So and potassium thalamide. Okay. So this is further reacted with the alkyl halide. So your what alkyl halide is taken? It is a primary alkyl halide. So we need to take a primary aliphatic. Okay, primary aliphatic alkyl halide. Okay. Now this it will undergo a SN2 mechanism, and what it will form? It will form C double bond O, C double bond O, and your K is substituted by the R group. Okay. Now further, you are going to treat it with a what? NH2, that is primary amine. This primary amine, okay, what will happen? Your thalamide will, so your the cleavage of bond takes place. So you will get C double bond O OH, C double bond O OH. Okay, you get a phthalic acid. What you get? You get a phthalic acid, and this is N-alkyl thalamide. N-alkyl thalamide plus primary amine. This is a primary amine. Okay, so you yield a primary aliphatic amines from this particular reaction. Okay, is it clear? Is it clear? So this is a Gabriel thalamide synthesis. Okay, so the starting reactant, we have a, what we have? We have a thalamide. Okay, we have a Gabriel thalamide. Okay, here you have a phthalimide. So this phthalimide, you are going to treat it with what? KOH, that is potassium hydroxide, a strong base. We are going to get a N potassium phthalimide, okay, potassium salt of phthalimide. Then we are going to treat it with your alkyl halide, okay. This alkyl halide will undergo a SN2 reaction and it will give you an N-alkyl phthalimide. This N-alkyl phthalimide will react with the primary alcohol to give you phthalic acid and primary amine. Okay, so this is the reaction. So let us go for the next one. So it was option number C. Next one, the correct order of the increasing basicity of methylamine, ammonia and aniline is A. Methylamine is less than aniline and ammonia. B. Aniline is less than ammonia and methylamine. C. Aniline is less than methylamine, ammonia. And D. Ammonia is less than aniline, which is less than methylamine. Tasmiya has answered as B. Vedvati has answered it as A. What about others? Okay. So Vamshi Krishna, Basava and Komala has, Vamshi Krishna and Basava has answered it as B. Komala has answered it as D. Okay. So let us see for, okay. So this particular question. Now, when you see, let us write the structures first. Okay. So first we have methylamine. So this is your methylamine. Next you have ammonia, NH3. Next you have aniline. Okay. Now these are the structures of your amines. Okay. Sorry, aniline is NH2. Okay, now this is the structures. Now you can see that in aniline, what is present? In aniline, lone pairs of electrons are present on the nitrogen. Okay, and these lone pairs of electrons will be involved in what? You have a benzene ring. So it will undergo delocalization. Okay, it will undergo what? Delocalization of this electrons with the benzene ring, right? So the lone pair of electrons which are present on the nitrogen will be involved in the delocalization with the benzene ring. Okay, and those and it is not available for protonation. Okay, it will not be available for protonation. You cannot protonate it. Protonate means what? Attack of electrophile cannot be taken place here. So what you say, your methylamine. Okay, so methylamine is the stronger base. So methylamine is a stronger base than your ammonia. Okay, because of the plus side effect. Because CH3, because of the presence of CH3, that is methyl group, it is having a plus side effect. Okay, so it can easily donate the electrons to the nitrogen, right? So it is having a plus side effect. So because of plus side effect, what will happen? The basicity of methylamine will be more as compared to that of NH3. Okay, the effect of methylamine increases the electron density on nitrogen. So because of that, it will become more basic than ammonia. Because you can see, if I write the structure, okay, if I write the delocalization of ammonia, that is your aniline. So this is lone pair of electrons. So that will undergo the what? Delocalization. So how the delocalization will take place? So this will form NH2 plus. Okay. So here what will happen? So this cannot be protonated. Okay, so here it cannot be protonated. So because of that, this is least basic. This is least basic. And here you can see, because of the presence of the CH3, it can donate the pair of electrons to the nitrogen. So what will happen? Because of plus I effect, it increases the basicity. So option number B. Okay, aniline is less than ammonia, which is less than methyl aniline. Okay, so who all have answered it as option number B? Basava, Vamshi Krishna, okay, and Tasmiya. Okay, so very good. So B is the correct answer. Okay, let us go for the next one. An isocyanide is prepared by A. Friedel-Crafts reaction, B. Perkin reaction, C. Carbalamine reaction, and D. Woods reaction. So what is isocyanide, students? What is a isocyanide and how this is prepared? How is this isocyanide prepared? RNC. Okay, whenever you have a NC bond, don't want R. So whenever you have NC, it is isocyanide. And whenever you have CN, it is cyanide. Okay. So remember, NC and CN is different. So we are talking about this and not this. Okay. So isocyanide. So now when we are talking about isocyanide, so how it is prepared? It can be prepared by a reaction which is called as carbalamine reaction. Yes. Bhuvan, Vedvati, Siddhanagowda, Tasmiya, Komala and Basava. Yes. Correct. Your answers are correct. It is option number C. A very famous reaction, that is carbalamine reaction. So let us see what is this carbalamine reaction. We have a primary amine. Okay, we take a amine. We react it with KOH. Okay, that is potassium hydroxide in the presence of chloroform. Okay, in the presence of chloroform, you get a isocyanide plus 3KCl plus 3H2O. Okay, so what is obtained? Isocyanide is obtained. Very important and a very famous reaction. Okay, let us go for the next one. Which one of the following reaction takes place when a mixture of concentrated HNO3 and H2SO4 reacts with benzene at 300 Kelvin? Which of the following reaction takes place when a mixture of concentrated HNO3, okay, and concentrated H2SO4 reacts with benzene at 300 Kelvin? At 300 Kelvin. Which of the following reaction takes place? Sulfonation, nitration, hydrogenation, dehydration. So you should know where this reagent is used. Okay. Vedvati, Tasmiya, Bhuvan and Komala has answered it as B. And yes, B is the correct answer. Okay, for nitration. For doing the nitration, we are using what? We are using the concentrated HNO3 and H2SO4 solution. Okay. So at 300 degrees Celsius, you will get what? Meta and or this what? Your meta dinitrobenzene. Okay. So in which of the following it takes place when a mixture of concentrated HNO3 and H2SO4 reacts with benzene at 300 degrees Celsius. So you get a nitration reaction. Okay. Let us go further. Aniline Aniline in a set of the following reaction yielded a colored product Y. So this is a reaction. Okay, so this is a reaction. So let me write the reaction here again. So you have a aniline. You are going to treat it with NaNO2 in the presence of HCl. Okay, at 273 to 278 Kelvin. What you will obtain? You will obtain X. This you are further treating with NN dimethylamine aniline, sorry, NN dimethyl to give you Y. Now, what is this Na2 plus HCl? Okay, this is a nitrous acid. So this produces you nitrous acid, that is HNO2. Okay, so this will produce nitrous acid and this reaction is called as diazotization reaction. Okay, so this is NH2. So diazotization reaction, and what you will obtain? You will get N2Cl. Okay, plus and minus. So this is a diazonium, benzene diazonium chloride. Okay, this you are further going to treat it with what? You are going to treat it with what? Yes, you are going to treat it with NN dimethylamine. Now, how is the structure of NN dimethylamine? So benzene, okay, with N, then CH3, CH3. So this is your N. At NN position, you have dimethyl aniline. Okay. Now, what you are going to get the product? Just see. You are going to get. So here is your. So I'm writing the flip. Okay. So at this carbon, so your this nitrogen will go and attack. So what you'll get? You'll get N double bond N. Then you will get, so not this. So this is N. This will attack your here. Okay. So N double bond N. N CH3 CH3. So this is the compound. So which it is? Option number A. Yes, Tasmiya, Vedvati and Komala has answered it as A. Very good. Okay, so this is the answer. So with sodium nitrate and HCl, okay, it is acting as a this what it produces diazonium salts. Okay, so thus it is used in the preparation of benzene diazonium chloride. Okay, fine. So let us go further. Aniline is an activated system for electrophilic substitution. The compound formed on heating aniline with acetic anhydride is. Okay, what is the answer? Aniline is an activated system for electrophilic substitution. The compound formed on heating aniline with acetic anhydride is. Okay, Tasmi has answered it as D. So let me write the structure of aniline. So this is my aniline. Okay. So aniline, I'm going to treat it with what? Acetic anhydride. So acetic anhydride is CH3COO, C double bond O, CH3. So how we write acetic anhydride is like this. Okay, just I have written it like this. So this is the acetic anhydride. You write regularly, right? So I have written like this. So this is acetic anhydride. I'm going to treat it with aniline. What I'll get? So my active center is, so I have hydrogen. So one of the hydrogen will be replaced. So it will be replaced by a acetate group. Okay. So it will be replaced by a acetate group. So NH C double bond O CH3 plus CH3 C double bond O OH. So whatever the hydrogen, one hydrogen here. So one hydrogen, another hydrogen. So this hydrogen will go and combine with this. Okay. And here this will get attached. So NHC double bond OCH3 and CH3 C double bond OH. Okay, so what is the product? 12th one, it is NHCOCH3. Option number D. Yes, Siddhana Gowda, Vedavati and Komala has also answered it as D. Very good. Okay, I hope you are understanding. So aniline, okay, it is an activated system. So when you have an electrophilic substitution reaction. So with so this is a product obtained when you heat it with acetic anhydride. Okay. Which of the following is more basic than aniline? A. Triphenyl and amine. B. Paranitroaniline. C. Benzyl amine. And D. Diphenyl amine. Yes. Okay. So Shri Krishna has answered it as C. Komala has answered it as C. Uh, Tasmi has answered it as C. Okay. Vedvati has also answered it as C. Okay. Tasmiya, in which group I have to add you? Tell me the group name so that it will be easier for me. Okay? Fine. So just drop in there. So which of the following is more basic than NLE? Fine. So let me see what is the answer. Okay, so all have told it as C. Okay, so most of you have answered it as C. So here, so triphenylamine and you have aniline. Okay, so which is more basic than aniline? So this is your aniline with NH2. Okay, so here when you have a benzyl amine, so when you have a benzyl amine, so N, so what will happen there? So benzylamine is more basic. Yes. So benzylamine, triphenylamine, diphenyl, then para-nitroaniline, triphenyl, this amine. Okay. So your benzylamine, okay, it is more basic than aniline. Because the reason again same, because there is lone pair of electrons are present on the nitrogen. Okay, and this it is in conjugation with the benzene ring and it is not available readily for the attack. Okay, so benzylamine okay, in other cases, but in benzylamine what happens, the nitrogen is not directly attached with the ring, right? So lone pairs are not conjugated with the system. So in other systems like para-nitrophenol and all, so para-nitroaniline, okay. So other structures you can see that the lone pair of electrons are there, so it can be involved in the conjugated system. But in benzylamine, it is not involved. So option number C is the correct one. Okay. Okay, let us go for the next one. Consider the following sequence of reactions. Okay, so compound A on reduction gives you B, which on treatment with HNO2 gives you ethyl alcohol. Okay, what is the compound A? Okay. Yes. 17th. Let us solve. So these are the options where you have. So you have a compound. So you got the product as CH3, CH2OH when on treatment with HNO2. Okay. So if I take a cyanide, so if I take CH3CN, okay, and if I do reduction, what I'll get? I'll get CH3, CH2, and H2. Okay, I'll get reduction. So what is happening here? I am adding hydrogen across the carbon and nitrogen. Okay, so CH3, CH2, NH2 is formed, that is ethylamine. This I am treating with HNO2. I'll get what? I'll get CH3, CH2OH. Okay, so option number D. Okay. So let us go for the next one. The compound obtained by heating a mixture of a primary amine and chloroform with ethanoic potassium hydroxide is. Yes. Okay. Vedvati has answered it as A. Basava has answered as A. Komala has answered as A. Tasmi has answered as C. Okay. So let us see now. 18th one. Okay. Now here the compound obtained by heating a mixture of primary amine. So let us take CH3, CH2, NH2. Okay. Ethylamine is a primary amine. I react it with chloroform in the presence of ethanoic KOH. What we obtained? Okay. We obtained a CH3, CH2, NC plus 3 KCl plus 3 H2O. H2O. Right. So this is what? This is a alkyl isocyanide. Yes. So this is a carbalamine test. Yes. Okay. So it is option number C is the right one. Very good. So whoever has answered it as option number C is a correct answer. Okay. Okay. Let us go for the next one. So which one of the following statements about primary amines is false? A. Alkyl amines are stronger bases than aryl amines. B. Alkyl amines react with nitrous acid to produce alcohols. C. Aryl amines react with nitrous acid to produce phenols. And D. Alkyl amines are stronger bases than ammonia. So which is the false statement about primary amines? Okay. Vamshi Krishna has answered it as C. What about others? Tasmi has answered it as C. As others? Yes. Okay. So yes, option number C is correct. So aryl halides, okay, aryl amines, they do not react with nitrous acid to produce phenols. Okay, so this is correct. The rest all are the correct this. So alkyl amines, aryl amines are stronger bases than aryl amines. These all the statements are correct about primary amines. But aryl amines, okay. So the aromatic amines, they do not react with nitrous acid. So primary amines can be distinguished from secondary and tertiary amines by reacting it with. So how can you distinguish with this secondary and tertiary? A. Chloroform and alcoholic AOH. B. Methyl iodide. And C. Chloroform alone. And D. Zinc dust. Okay, Vedvati has answered it as C. Vamshi Krishna has answered it as C. Tasmiya has answered it as A. Yes. Others? What about others? Okay. Komala, Tasmia, I've answered it A. Okay, so let us see. So primary amines. So 24th. Okay. So here we know that primary amines, okay, can be distinguished from secondary and tertiary by reacting it with, okay, so option number A. So if you react it with chloroform and alcoholic AOH, that is, it will give you carbalamine taste, right? So primary amines only can give you carbalamine taste. Secondary and tertiary, they won't give carbalamine taste, okay? So the carbalamine test, so if it is a primary amine, so you'll get a foul smell, okay, very dirty smell. You'll get a very dirty smell because of the isocyanate, okay, whatever is produced. So from this you can distinguish the primary, secondary and tertiary alcohols, okay, that is tertiary amines. Next one, methyl cyanide can be converted to into acetic acid by one of the following reactions: A, reduction; B, hydrolysis; C, electrolysis; and D, carboxylation. So methyl cyanide. Okay, methyl cyanide, it can be converted into acetic acid by what of the following reaction? Yes. So methyl cyanide is CHCCN. Okay, it can be converted into acetic acid. This is acetic acid. How it will be converted? If you do hydrolysis. Okay, if you do hydrolysis, that is acid hydrolysis, what will happen? Then CH3. So your CN group is converted into C double bond O and OH. So if you do hydrolysis, so option number B. So if you do acid hydrolysis, you will get, yes, option number, whoever has answered option number B is the correct answer. Let us go for the next one. So aniline is reacted with bromine water. So let us follow this reaction. So aniline is there. So aniline, what we have done, aniline, we are reacted it with bromine water. So this is a bromine water. Okay. And the resulting product is treated with an aqueous solution of sodium nitrate. So what we yield after getting this, we get a tribromoaniline, right? NH2. So NH2, Br, and Br. So we require here 3 moles, right? 3 moles of Br2, 1, 2, 3. So this I'm going to treat it with what? NaNO2, that is sodium nitrate, and dilute HCl. So what I'll get after this? So this is my what? This is 2,4,6 dibromo aniline. So this I'm going to treat it with what? Sodium nitrate in the presence of dilute HCl. So what will happen now? Add the this, so rest all will remain the same. So Br, Br. So this will be N2Cl, right? So at your amine group, your benzene diazonium chloride is formed. Okay. So this further I'm going to treat it with what? Dilute. Okay. So the compound so formed is converted into tetrafluoroburate. So that is, it is converted into tetrafluoroburate. Okay. So which is the subsequent heated dry, the final product is. So what is the final product obtained? Yes. So I'm going to treat it with what? I'm going to treat it with a tetrafluoroborate. Okay. So I can take sodium borofluoride. So what will happen now? So whatever the Cl is there, so that will be replaced by your BF4 group. So N2 plus and BF4 minus. So this is a negative, this is a positive, right? So you get Br your Br, and your Br. So what it is? It is a disonium tetra fluoroborate. Now this, I'm going to heat it. I'm going to heat it. So after heating, what will happen? I will get a, okay, I'll heat this. I'll get your F. Okay, here I'll get Br. Okay. Br, and Br. So there will be elimination of what? There will be elimination of N2. There will be elimination of BF3. Okay, so you get a 2,4,6 tribromofluorobenzene. Option number D. Yes, option number D. Okay, so you get a 2,4,6 tribromobenzene. So these are the set of reactions you have to follow. Okay, let us go for the next one. So, so this is a reaction. So you have to identify what is the A. What is the A? So A can be your formaldehyde, trichloromethane, nitrobenzene, and toluene. Okay, so my last product is what? My D product is N-methyl-aniline. What it is? N-methyl-aniline. Okay, so this is N-methyl-aniline. Means what? It should be a benzene substituted at least. So here, what is the benzene substituted? Trichloromethane is a no. Toluene is CH3 group, and this is nitrobenzene. Okay, so nitrobenzene. Let us take nitrobenzene and see. So nitrobenzene, I can do nitrobenzene. If I take nitrobenzene, I can do reduction and I can convert it into your this what reduction I can do, and after reduction I will get what? Aniline, right? I'll get aniline NH2. This NH2, if I treat it with what? CHCl3 plus KOH, what I'll obtain? I'll obtain this isocyanide. I'll obtain isocyanide, that is N triple bond C. Okay. Now this is a C, this is A, this is B. Now this isocyanide, I'm going to do reduction. I'm going to do reduction to give you what? N-methyl. So what is happening across the nitrogen, hydrogen is added, and across the carbon, hydrogen is added. So yes, so we can do option number C. Okay, so but we know that from nitrobenzene, if we do reduction, okay, if we do reduction, what we will do? Okay, from nitrobenzene, we can do reduction, we can obtain aniline, then we can follow the set of whatever is given, and we will get the required product. Okay, so option number C is the correct answer, nitrobenzene. Yes, whoever has answered it as option number C, very good. So let us go for the next one. So in the following reaction, so this is set of reaction, acetamide reacted with P2O5, you have to heat it, you get a Y. Further reacted with water in the presence of HCl, you get Z. This on further treatment with NaOH in the presence of calcium oxide gives you methane. What is identify the Z? You have to identify the Z. Yes. So acetamide is CH3, C double bond O. Okay, NH2 acetamide. So this I'm going to treat it with P2O5. Okay, and I have to heat it. So after heating, what I'll get? I'll get CH3. Okay, C and triple bond N. Okay, so after heating, water molecule will leave. So if the water molecule leave, then you will get a triple bond N. This further, I'm going to treat it with what? H2O in the presence of HCl. Again, I have to heat. Then what I'll get? So CH3, okay, C. So I'm going to add CH3, C. Then I'm going to add what? C double bond O, OH. So H2O. So across this OH, and here your O double bond O, C double bond O, and here OH. So here what will be eliminated is ammonium chloride, NH4Cl. Okay. Now this will give you acetic acid. This on further treatment with what? NaOH and calcium oxide. What you will get? You will get methane. Okay. So what is happening here? Your H2O. Okay, water molecule is lost, plus Na2CO3 is lost. Okay. So carbon dioxide, whatever is produced, it is combined to give you Na2CO3. So this is also lost. So minus, and water is also lost. So the answer is what? Acetic acid, B. Yes, option number B is the correct answer. Okay, let us go for the next one. Ethyl isocyanide on hydrolysis in acidic medium generates. What does it generates? Ethyl isocyanide. Let me write the structure. So this is ethyl isocyanide, NC. NC. So I'll do hydrolysis of ethyl isocyanide. Okay, H2 in the presence of H plus ions. What you will get? You will be adding H2. So it will be CH3, CH2, NH2. Okay, plus HCOOH. So it gives you one chloroalkane. It gives you one chloroalkane. So ethylamine salt. Okay, you get a salt and one methanoic acid. Okay, you get a methanoic acid and you get a ethylamine. Okay, ethylamine. So option number D. Option number D. So when aniline reacts with oil or bitter almonds, condensation takes place and benzyl derivative is formed. This is known as. This is known as. Yes. So, okay. So what is formed here? Benzyl derivative. That is benzylidene aniline. Okay. So this is known as the Skiff's base reaction. It is called as the Skiff's base reaction. Sorry, Skiff's not reagent, Skiff's base reaction. Okay, option number C. So benzaldehyde, it reacts with the primary aromatic amines and it forms Skiff's base. What it forms? It forms Skiff's base. Option number C. Okay, it forms Skiff's base. Okay, the end product of the reaction. What is the end product of the reaction? Ethylamine reacting with HNO2 to give you compound A, which further reacts with PCl5 to give you compound B, which further reacts with HNH2 gives you C. What is the end product? Yes. What is the end product obtained? So if I write ethylamine C2H5NH2, if I treat it with HNO2, what I'll get? Nitrous acid, ethylamine. It will be converted into alcohol. Okay. This alcohol, further if you treat it with PCl5, phosphorus pentachloride. So OH group will be replaced by chloride group. So C2H5Cl. This further reacted with NH3. Okay. Further reacting with NH3, what will get? Again, this Cl group will be replaced by NH2. So I'll get the ethylamine. I'll get ethyl amine. So NH2, I'm converting into OH. This OH, I'm treating with PCl5. So Cl group is replaced. Further treating with NH3 to give you again back my methyl amine, ethyl amine. So option number B. What is the answer? Option number B. Is it clear? Yes. So any doubts up to here? So nitrobenzene on further excessive nitration gives. So if there is a nitrobenzene and if you do what? If you do excessive nitration, there is a nitrobenzene. And if you do excessive nitration on that, then what you will obtain? what you will obtain. So if you do more nitration, again, if you treat it with concentrated HNO3 and concentrated H2SO4, yes, what you will obtain? Yes, no replies? You will obtain a dinitrobenzene. Okay, so your nitro group will be attacked at the this. So you'll get a M nitrobenzene. So that is meta dinitrobenzene. So you'll get meta dinitrobenzene as the product. Okay. So option number B. Okay. What is Hinsberg reagent? What is Hinsberg reagent? Do you know what is Hinsberg reagent? What is Hinsberg reagent? Okay, so this is a Hinsberg reagent. Option number C. Yes, Vedvati, your answer is correct. Very good. So option number C. Okay, Hinsberg reagent is option number C. Yes, benzyl sulfonyl chloride. Yes, very good. Okay, so it is benzyl sulfonyl chloride. Okay, which is called as the Hinsberg reagent. Okay. Okay, so these are the same reactions. Okay. So take this one question. So six, we have done this. Okay, but still you can do. So we have a nitrobenzene. Okay, I'm going to convert, treat it with tin HCl. I'll yield what? Aniline, right? Because I'm doing reduction. This I'm going to treat it with what? Benzyl chloride, acyl chloride, C double bond O, Cl. Okay. So what I'm going to obtain here? So I'll get a N substituted product, that is your 60. Okay. So it will be N C double bond O. Yes. N C double bond O NH. So this will attack here NH. Okay. And so this is your benzene. So with the benzene ring. So the CO double bond O and NH group gets attached. You get a benzene plus HCl. So option number B. Yes, Vedvati and Vamshi Krishna has answered it correct. Very good. Okay. So by this we have completed. So most of the questions, okay, from amines chapter. Okay. So this completes our chapter amines. Okay. So today we have completed a chapter amines. So tomorrow, the last chapter of UC second year, that is biomolecules. So tomorrow we are going to study about biomolecules. Okay. So today after this session, so you'll be getting the Google links. Okay, Google Forms for test of all the topics today which we are done. So please answer the test. Okay. So go through the paper and just evaluate yourself. Fine. So what you can do, you can take some additional questions from the last year solved papers. Okay. Last year papers and you can solve them. Okay. So that you can understand, like you can evaluate yourself how much you have understood. Okay. So I hope you have understood all the things which are told today. Okay. So, okay. So, any doubts? Yes, any doubts, students? Okay, fine. So, I'll end the session here. Okay, we'll meet in tomorrow's class. Thank you.